All right. Good morning, everybody. Thanks for being patient. Running a couple minutes late here. Had a couple things happen right before 8 o'clock that set me back. One was a puppy that needed attention, or there was going to be a problem, and a couple other little things. So thanks for being patient, and we will get into things. So, let's see, log in here. Let's open up Canvas. So I did not have a chance to check yet to see if more people have signed up for the online class, or for the online homework. But you definitely need to do that. Okay, I'm imagining I would bet there's still people who need to do that. You should do it sooner rather than later. That is not something to wait on. Usually having that homework late causes problems, which means you don't get homework assignments finished, which means they either don't get finished or you do them at a later date for less credit or whatever. So want to make sure you're moving forward with things. And we've got, let's see, where are we here? So hopefully you are September 25th. You got a couple more days. Hopefully you're doing this part, the groups, the project groups part. You're forming your groups. You're picking out people that you can work with, and that will sort of be your support. You know, it's almost like a support group that you go to work on the group project, right? You're each going to be doing your own project. But if you figure out something that worked really well, you kind of had that little light bulb go on above your head and go, oh, I see how to do this. Share that with your group. And the reality is each of you in the group, as long as everyone's working hard, you're each going to have those light bulbs go off at different points. And you go, oh, this makes perfect sense to me now. And then you can help explain it to the people that are in your group, because it's just very helpful, right? You're all working on essentially the same projects. Or, you have it's different topics, right? You're all doing different topics, although within your group, you're probably doing a similar topic. So you can show what you do when you do a correlation, a scatter plot with a correlation and a line of best fit, and you figure it out, and you can show your group and go, here's what I think he's talking about. Here's what those videos are talking about. I think here's how it relates to our project. That's going to work really well when you're in a group and you bring that kind of thing in and you all help each other out. And I definitely have, like in my other classes when I do this, I have entire groups come to me with questions. And you know what? That's actually super helpful. I find that it's a great way to do it. A group comes to me and says, we were working on this, but we're not sure if we did this right. Right? Is this, and questions is a good one. We'll have the questions coming up. Hopefully your group comes to me and says, here's our survey questions. We're not sure if like number 3, did we do a good job on question number 3, or are we missing something? And I look over the questions and I talk to the group about it and we have a discussion. And sometimes I go, oh, you should definitely make this change. And sometimes I just have some suggestions and go, well, it might work well if instead of doing this one thing, you did this other thing over here, but it's your call. And then usually everyone ends up feeling better. They leave and go, oh, okay, I have a better understanding of what he wanted. And then we can kind of go from there, right? So form your groups. Those groups will be all set. Once we get the group set, we'll start talking about submitting survey questions, and we'll do that again. Some of you have already done it, but probably you will want to redo those questions since you have more information now. You've actually learned or are learning the chapters that are relevant to forming these survey questions, but it's not too early to start thinking about it. It's not too early to start asking, what should our topic be? And I see topics from all over the place. Like I've mentioned before, a lot of health topics, people's running habits, people exercise habits, people's eating habits. Those are always popular. COVID's a big one, right? What were your habits before COVID? What are your habits after COVID? And then there's always some other interesting ones that mix their way into things. One group in my other class is sort of doing people's opinions about the environment, right? And seeing if there's connections about the way people feel about climate change, and then connections to other things, right? Very, very interesting thing to pursue. So if you've ever wondered about something and people's opinions and if they're connected to other opinions, feel free to chase that down and see what you can do about it, okay? So I'll open this up. maybe let's see, where are we? I don't know. In the near future, we'll go to this. But for right now, be focused on one, getting your homework set up. For those of you who haven't yet, get like the whole process. Step 1, get the free 14-day trial. Step 2, work with the bookstore to get your permanent free license for the rest of the semester, and then you can start moving forward with stuff. Okay? Yeah, and then we'll go through there. So we have talked about, now we've got, let's see, is that right? So some of the things I talk about in the lessons might not exactly match up with where you are, like in these class meetings. The things I talk about might not specifically match up with the things you're looking at in the videos. And part of that is because there's things I don't really need to explain as much, like the mean. We can talk about the mean, but the mean's a pretty simple idea. You probably understand the mean from just from watching the videos. And most of you knew what you used to call it the average. So you kind of knew that idea anyway. So there's not much point in me spending a lot of time with it. We talked about it a little bit, but, or let's see, was that the other class we talked about? Anyways, we'll talk about a little bit things like that. But most of the time I'm trying to cover things that are more sort of subtle ideas, subtle connections, because that's a thing that's easy to miss in statistics. It's easy to come into statistics, try to memorize a bunch of things and go, yeah, look at me, I'm really good at statistics. I can do this hypothesis test and I can calculate a confidence interval, but then not know what those things mean or really how to interpret those results. That's the most important piece, is the interpretation of those results. So please keep that in mind whenever you're learning a new thing in this class. Is, do I really understand what this means, or am I just memorizing how to get a problem correct? Because on your project, you're going to need to understand what it means. You're going to need to understand how to do that thing. So keep that in mind. So I believe we left off last time with some, let's see, where were we? Did we leave off right before percentiles, I think? Yeah, because we talked about, actually, give me 1 second here to double check something. Wait, 23 hours ago. Oh, wait a minute. Sorry, kind of a... Give me 1 second here. Am I looking at the wrong thing? All right, my bad. Today's Thursday. So part of what I just told you was wrong because I'm thinking about my 15-week class instead of the 18-week class. You guys are the full speed class. All right, little off my game this morning. Sorry about that. So we are the full class. We're the full one. So the full semester class. Right, so we talked about z-scores last time. That's where we left off. We were looking at z-scores and going from there, right? Today's Thursday. That's the 18-week course. Okay, sorry for the confusion. I've got these... it's it's just rough. I've got three stats classes this semester, and they all start at different times. So sometimes you start thinking you're in one class, and then you're not. You're in the other one. So you end up repeating yourself or thinking that you go back and say things that you need to say again. So my apologies. So we left off with z-scores last time, right? Correct me if I'm wrong. If I'm still messed up, throw it in chat or something. But I believe we talked about z-scores. We did the example of two students in different classes, both doing the best on their class test, but then how would we compare who did better? And we used a z-score to do that. Z-scores are very helpful. Z-scores, like I said, come up in ways that you might not recognize. They come so just a correction then. I was looking at the wrong class in here because so when I talked about opening those questions up, that's the other class that's about to have their questions opened up. You guys already did this, so you should be taking the survey. Make sure that survey's getting taken because we really need to release that by like next week. We need those results getting released. So make sure that you're doing that. So you take the survey, you look at those, you take it. I'll release the results next week, and then you can start moving forward with your project. So if you haven't done that yet, please step up and help people, by taking the survey. You're helping your fellow students by doing that. So keep doing that. Okay, so if we keep going, what are other things that you need to know that you're going to use? So one thing are our percentiles. So percentiles are a way of keeping track of what percentage of the data is being accounted for. So for instance, SAT scores, at least they used to be done this way. I don't know I think they still do it this way, but SAT scores are usually given by an actual score that they give you. They'll say, you scored this much on your English portion or whatever they call it, and then this much on your math portion, right? And then they usually tell you where that puts you as a percentile. So they will tell you, this puts you in the 98th percentile, or this puts you in the 37th percentile. Essentially, what they're telling you is how much of the data is below where you are, right? So essentially, they're telling you what percentage of the people who took the SAT did you beat in this part of the test. And, that's kind of what people would like to know. When when I give out a test and they're saying, what's the mean? Well, what you'd really want to know is what's the percentile of my particular score. You want to know how many people in the class did I do better than? Am I at the bottom? Am I at the top? Am I in the middle? Am I in the top 3/4? And so on. So, percentiles give us a much more exact way of doing that. Now, percentiles are like z-scores in that the percentile applies to each point of data. Remember, you always kind of, this will help if you make this distinction. We have things where we measure the set, right? The mean, the mean is a measurement of the set itself, right? You can't take the mean of a single data point. You take the mean of an entire set. You take the median of the set. You don't take one data point and take the median of that data point. So there are measurements that we do on the set as a whole, and then there are measurements that we do that take the whole set into account, but that each data point has a different measurement, right? We saw z-scores were like that. Each data point in your set will have its own z-score. Now, you might have the same data point show up twice, so you'll get the same z-score for those 2 points. But for any data point that is distinct from the other points, you will get a distinct z-score. Percentiles are the same way. You will get a different percentile for each score that if it's like my example of test scores, for each one you calculate, you'll get a different percentile, okay? Now, you can calculate any percentiles you want. You could calculate the 79th percentile. You could calculate the 13th percentile. Or you can go the other way and you can ask, what is the 80th percentile, right? So college entrance officers and counselors do this sometimes, right? If you're trying to get into an elite school, they may take the SAT scores for that year and say, we only want students that score in the top 15% on the math portion of the SAT, and then they would have a different portion, or a different calculation for the English portion. But they'll say, okay, we want students that we're accepting to be in the top 15%. That means what? That means if you take the SAT scores or that cutoff, 15% of the scores will be above that cutoff, and 85% of the scores will be below it, right? So you would say that's in the 85th percentile. So you want students that are, in the top like that. So, so you can sit there and you can calculate it that way. You can say, okay, what's the 90th percentile? What's the 10th percentile? And you can go through and calculate what that score is. And then once you've calculated that score, the officer for the college admission just has to look, is the score at or above this cutoff, right? So you can do it either way. You can take a score and figure out its percentile, or you can take the set and figure out, well, what would be the 90th percentile? And then you can figure out if something's above or below that. Okay. So your official definition, sometimes in statistics you get these official definitions, and then you get like the way you're actually supposed to think about it. So percentiles are measures of location. We usually denote them P1, P2, up to P99, which divide a set of data into 100 groups with about 1% in the values of each group. So percentiles are kind of rough estimates. We don't get super specific, like exact with them or precise, because they're kind of an estimate. You're trying to get like, the 80th percentile may actually be like 79.8 points. Well, you might not be able to score 79.8 points. So then we would just say 80 is the cutoff, right? We would do it that way. So the 50th percentile, here's a helpful way of thinking about it. The 50th percentile is just another name for the median. And if you think back to the median, what does the median do? The median splits your set in half. You have the top half and the bottom half of your set, basically. The median, half of your data values should be above the median, and half of your data values should be below, right? So that's the same as the 50th percentile. For the 50th percentile, half of your data should be above, half of your data should be below that cutoff. So just think about that. We won't use percentiles a ton in this class, but they will come up from time to time. It may be something you want to talk about in your project. It may not. It's one of those things where it kind of depends if you think that it fits well or not. Okay, but you definitely want to recognize the connection between percentiles and the median. And then also another thing that comes up when you're trying to do like a box plot is quartiles. Okay, so quartiles are measures of location denoted Q1, Q2, Q3, which divide the set into 4 groups, right? And people go, wait, you said there were three denotations for the quartiles, but if you think about it, if you have a string and you cut it in 3 places, how many pieces do you have? You have 4, right? So if you want to cut a piece of wood into 4 pieces, you make 3 cuts, because you make 1 cut, you have 2 pieces. You make another cut, you have 3 pieces, and that last cut, the third cut, you have 4 pieces, right? So the first quartile, which is the first quartile, is the same as the 25th percentile. So I'm making these connections because once you make sense of one of them, the others kind of fall into place, right? So the 25th percentile, also known as the first quartile, separates the bottom 25% of the sorted values from the top 75%. So when we say the 25th percentile, that means that score beat 25% of the other scores, right? Whatever the data is representing, whether it's test scores or non-test scores. The 25th percentile splits things up into the lower 25% and the upper 75%. That's the first quartile. That's the 25th percentile, okay? The second quartile is just another name for the 50th percentile, which is another name for the median. So it starts to get a little silly here. It's just because that concept keeps popping up in these different mathematical ideas. So second quartile, 50th percentile, median. Those are all 3 of those are different ways of saying the same thing. So usually we just say the median, right? And then the third quartile. So if I just give you a second here, I'll just give you a second to kind of think about it. If try to figure out what would the third quartile represent, right? I'm going to give you a second to collect your thoughts, and then I'm going to tell you so you can kind of see if you're right or not. So ask yourself, do I know what the third quartile would represent? So the third quartile, right? You think quarters. If you have 3 quarters, what do you have? You have 75 cents, right? The third quartile implies 75%. That would separate the bottom 75% of the data and the top 25%. So whatever your third quartile is, 75% of your data will come in below that value. 25% of your data will come in above that value. Okay, so it helps you sort of split things up. This comes up, right? This comes up most of the time when you're doing a box plot. Okay, you may end up wanting to talk about quartiles. You may end up wanting to talk about percentiles. They can be useful. They can be helpful. But they definitely come up in a thing called a box plot. And you might be surprised, box plots come up more than you might think that they do. They can be especially helpful when you have a string of box plots and you're trying to show some change over time. So let me pull this up here. Let's see. Now, there's a couple ways to do box plots. So don't get too hung up on, well, I learned to do it this way. Here's another good one, actually. If I can see it. So I'll show you a couple different ways of doing it. Don't get too hung up on the particular way. Box plots are done different ways. These also used to be called box and whisker plots. They don't call them that anymore. They just call them box plots. But there's a little bit of variation. So when you see one, don't necessarily go, these people did it wrong. Some books teach it one way and some books teach it slightly differently. And you actually get a fair amount of this in statistics because percentiles, there's actually more than one way of calculating a percentile that leads out to very, very small differences in that percentile. The good news is we know that box plots and percentiles are kind of a rough estimate. They're not like meant to be super precise, right? And for the kind of work that you do, they're generally good enough. They're like actually pretty good. The amount that these things can vary is so small that it generally doesn't really matter. But just don't get, if you see someone doing it differently, don't get upset. They may have just seen it differently. So if you're reading an article with statistics in it and it looks a little bit different, sometimes these things are just done a little differently. All right, let's see if I can blow this up. Okay, so you may see box plots oriented horizontally. That's perfectly legitimate. You may see them oriented what did I just say? You'll see them both horizontally and vertically. So there's not a right way to do it. You just have to make sure that you're labeling everything properly. Okay. A lot of times it's more about how things are going to fit on the page. So like here, it made sense to have it horizontally because it's taking up less of the page. But if we were doing 5 box plots simultaneously, it might make sense to do them vertically and then just place them next to each other. So that's really all that matters. You don't see that as much with other graphs. You don't normally see someone take a histogram and like put it on its side. But with box plots, you see that all the time. You'll see horizontal, you'll see vertical. It's just it's a normal thing. So the box plot is another way of helping you get a sense of your data. Okay, it's helping you kind of see how things are spread out. Remember we talked about the standard deviation? The standard deviation gives you a pretty good understanding of how spread out your data is. However, it just gives you an overall measure of the total spread of the entire set, right? Well, The box plot allows us to get a little bit more specific and see which parts of our data are spread out, right? So, for instance, if we took the ages of people in this class, and we would see that the ages are, there's a spread to the ages, and we could say, well, here's the standard deviation for the ages. But what that wouldn't tell us is that things are kind of bunched up around 18 to 22. And then once you get past 22, the spreads really starts to increase, right? A few people in their mid-20s, couple people in their late 20s, maybe someone in their 30s, someone in their 40s or something. So it gets more spread out as it goes that direction. Well, you can't really tell that from just the standard deviation, right? The standard deviation just gives you an overall measure of how spread out all the points are, essentially. Well, if you get comfortable with box plots, they can tell you where your data is bunched up and where your data is more spread out. And we'll look at some examples like that in a minute. Okay. So here's your basic setup for the box plot. So here, they used to call these box and whisker plots, like I mentioned. They don't really call them that anymore. They just call them box plots is kind of how they're called now. But you've got your box, which makes sense. It's a box, right? It's a rectangle, which is kind of then split into two rectangles. And then you've got these things called whiskers, these lines coming out on the end. Sometimes people put a little vertical mark on the ends of those. Sometimes they don't, right? I wouldn't worry about it too much. There's also what's called a modified box plot. I wouldn't get too stressed out about it for this class. Just recognize there's a few different ways of doing a box plot that people call a box plot, where you can put in the outliers and stuff like that. Okay, so basically what you do is you have your axes. Remember, I've stressed this, and it's something that I look for in the project. Any visual that you make should be well labeled. I should never have to look at a visualization that you make for statistics and ask, what is the x-axis? What is the y-axis? What is your units for the x-axis, right? If you just put time on the x-axis, then I still can ask time in what? Centuries? Seconds? What are we talking about here, right? Just make it explicit. Time in days. And then the reader knows, right? And then whatever your other y-axis is, just give that indication. These are the counts of people who bought fast food at McDonald's between 11 and 12. Or so, whatever it is, right? You're counting things on different days or something. Just put that description in there and make it very clear. And they've got some, they've got their axes and sort of this is just a general box plot, but you'd want your description in there. Once you do that, this thing where they write whisker, box, whisker, you don't write that. That's to let you know the parts that are called the box and the whiskers, in case anyone ever talks about it. But this whisker term is kind of going away. Because most people don't learn it as the whisker anymore. If you're talking to someone older, they might talk about box and whisker. It's the same thing. So how do you know where these other points go? Well, what we have is a minimum down here, a maximum up here, but the line doesn't go all the way through. The line goes up. You start at the minimum. You have a line up to the lower quartile. Then you start a box. That box goes up to the median, and then you have a second box connecting to it that goes up to the upper quartile. And then the upper quartile has a line going all the way to the maximum. I know when you first see this, it looks really strange, and you're like, this seems overly complicated. Why is this so important? What I'll tell you is box plots are more important than I thought they were. When I first learned box plots, I thought this is just some weird representation. I don't 100% get it, and I don't see why it's useful. I'm not going to pay too much attention to it. But what I will say is I'm often surprised at, and I've sort of learned over the years, I've learned why box plots are so important. Box plots come up in statistical work that when you read some statistics that's been done, you see a lot more box plots than I ever thought that you would. And part of it is because they give you that indication in a way that's different from, say, a histogram. It gives you that indication where your data is bunched up, and it can be very helpful. So here, everything's kind of spaced out pretty evenly, right? But if you think about it, if this is our minimum right here, and this is our lower quartile, then what does the length of this tell us? That tells us how much of our data takes up 25%? Like, so 25% of our data will fall right here. Well, from the lower quartile to the median, that's another 25%. From the median to the upper quartile, that's another 25%. And from the upper quartile to the maximum, that's that highest 25%. So each of these segments of the box plot actually represent 25% of your data. And what you'll notice when you get into more interesting ones is sometimes they're bunched up. Like if we looked at, if we were to look at the ages in this class, right, and this would actually be interesting to do since that was a question that came up, this lower 25% would probably be shorter, right, because you've got ages starting at, say, 14, and then do you need some? Hold on one second. Okay, sorry about that. Little chaotic around the house this morning. So where was I? Oh, so you would see this. The length of this one would likely be shorter because you can take Ventura College classes at 14 under certain conditions, but most students coming in are like 18 to 20, sometimes up to 22. So you would see this bottom 25%. Would sort of be compacted, right? Actually, yeah. So anyways, the shape here, I'd have to think about how that would look. The shape here would get distorted. So you're seeing one where they're all the same lengths, essentially, like it's meant to sort of be spread out. You normally don't see them like that, right? Normally you see them plotted a little bit differently. But that's the basics for making those. StatCrunch can make your box plots for you, so you can decide if you want to put them into your project or not. All right, here's another version where they call it again the box and the whiskers, though we don't call it that anymore. So even here they're calling it a box plot, but you can see we've got our median, which is the second quartile. We've got our quartiles here, the min, the max, and so on. So that's what those box plots look like. When we're going to do them that way. Sometimes, let me show you an example of what I mean. Oh, here's a good one. This is like exactly what I'm talking about. Here's someone they're using Python to create box plots, which is kind of cool. But see what we have here? We actually have here a bunch of different box plots. And these actually look a little different. These are what we call those modified box plots, where they stop the bar before the min or the max, and then they list the rest as outliers. You don't have to learn how to do that piece. But what I'm just trying to show you here is what a lot of times you'll see is people put a bunch of vertical box plots here, and you can see how that shape is changing. Right, you can see how things are changing over time. So if these were, like, you'll see temperatures done this way, right? You'll have 12 of them, and you'll have the highest and lowest, like you take the temperature data each day, maybe the highs and then the lows, or there's lots of different ways you could do it. And then you put them together, and then you can see, oh, this month has a lot more variability in the temperature. This month, the temperatures are very consistent. Like January's most places, the temperatures are pretty consistent, like on the colder side. Even usually in Ventura, the temperatures are pretty consistent in January and usually in February as well. There's not a huge amount of variation. Whereas in, say, June, we can have huge variation in our temperatures, right? You can have, one day it's overcast and kind of cold, and you go down to the beach and it's cold and windy. The next day, the sun is shining and it's hot down at the beach, right? So you can have a lot more variation. So then as your box plots go on, you can see that, and you can see how your data spreads out each month throughout the year. So that's just an example of how, one useful way to see these box plots. And I see this a lot more than I sort of expected when I was in an intro to stats class, how often you see these vertical box plots where you have a few of them together. So that's just so you kind of are comfortable with the box plots, okay? And remember, the box plots use those quartiles, and quartiles are based on percentiles. So see how we're kind of putting all these pieces together to form kind of a bigger idea. Okay, we'll skip that part. We don't need to know about that. Let me go back here. Okay, let me try something since we have a couple minutes here. Let me go back here and go. Okay, so on the survey, we are at 24 responses, so that's good. A bunch of you, maybe 9 of you have gone in there and done it since I talked to you a couple days ago. Thank you to those people. That's great. You're helping out people in the class. We still have people that's still not where we need it. We need that number to be about 9 or 10 people higher. Will really make things better. So. And we still have more than 24 people participating in the course, doing homework and stuff like that. So we really need everybody to get in there and get that survey taken, because if we, the longer we have to wait, that's the less time you have your data available to you. So it would be great if I could release that data next week, but I can't do it until we have enough data to actually be able to do our work properly. So those 9 people or 10 people, 11 people, whatever it is, I mean, technically like 16 people, but I think a couple people have kind of fallen off. But we should be able to get about 35 people taking the survey. We really need to get to that point. So if you're still procrastinating on that, please do it today. I know it's easy to forget. Just right when we're done today, just click that link, take the survey, and then I can get stuff out to people, and we can move forward with stuff, okay? So we've got that. Sorry about the confusion at the beginning of class when I was talking about questions and stuff. Obviously, you've submitted your questions already, so we're good with that. You're taking the survey, and we're moving into stuff. Let's take a look at StatCrunch. We can make this bigger. So we've got a few minutes here. I can just kind of show you some stuff with the StatCrunch. I've showed you how to do that 5-number summary, and then we should be able to do the box plot as well. I just have to remember exactly where it is in the menu. But let's say we've got, oops. Okay, so we've got our data here. We can call this ages. Let's put a couple more in there. Let's go. Just so we've got 20 of them. We want our box plot. So see, you go into your graph. You're in StatCrunch. You go over to graph. You go over to box plot. You click it, and it says, what do you want to do? Well, we only have one column. So I'm going to make it ages. And then you have some different choices. Remember, you can a lot of times you can go back. Like, look, here's an x-axis label, y-axis label. So you can put your labels right in here, right? You can put them right in there and try to, so you can go back and make it good. Remember, I said your graph should always be well labeled. We'll put your stuff right in here. It says it's optional, but you can get a title, an x-axis label, y-axis label. It's right in there, right? But you can mess around with that while you're making these. But let's go ahead and, and see here they have use fences to identify outliers. So I told you there's different ways of creating those box plots. Well, StatCrunch gives you some of those options as well. And then you can have draw boxes horizontally. So it gives you if you want to do it vertically or horizontally, however you want to do that. You can have markers for the mean and median. There's a lot of different customization that you can do for this. And luckily, it's easy to go in and make those changes. So you can try something, see if it works. Oh, it doesn't work, and then you stop. So here's our box plot. See how it's not perfectly spread out? This one's done a little differently. This is that modified box plot where these are actually outliers right here. And if you go over it, it'll actually show you, oh, this is age 48. That's an outlier. This is age 34. That's an outlier. So what is this? When I showed you the box plot, the way we learned it was this would have been the maximum. You'd have the minimum, the maximum. The way the modified box plot works is it cuts it off right before any outliers. So this would be the maximum value that's not an outlier. Remember we talked about there's specific ways that you can measure if something's an outlier by how many standard deviations away it is from the mean, which is really to say what is the z-score of these points, right? But see how it's kind of lopsided? We have a lot of our data compacted down here, and that's what I said we would expect, right? Remember, these are right around 18, 20. The 18, 20, 18, 19, 20, those are like all stacked right on top of each other. There's a lot of students in these classes that are 18, 19, 20 years old. So that means all of our data hardly takes up any room because it's all the number 18 a bunch of times, the number 19 a bunch of times, and so on. Okay, so by looking at this, we can see, oh, I see, we've got a bunch of people that are young, and then as people age, you see fewer and fewer people in a community college stats class, right? So we can go in and edit that, and I could say, I really want to see that thing horizontally. We can get rid of those fences, and we do it. Now it's more like the box plot that you're used to. So what I changed was, in case you need to see it, I changed use fences to identify outliers. We're not identifying outliers anymore. And I had it do it horizontally. So then I compute it. And here we're looking at essentially the same information, but it's now horizontal. I didn't go in and put in ages because it knows that's what we drew from, but I didn't label everything. I didn't put in a title, which you should do. But you can kind of see how this works now, right? And then you can see, like we looked at before, you could put a few of these together if you wanted to be fancy about it. Okay, so StatCrunch makes it real easy to make your box plots. Just like most of these graphs are super easy to make in StatCrunch because it just does it for you. You just have to figure out, how do I want it to look, right? How do I want things to be specified? And by going in and just playing around with the options, you can figure out the different things that you want to do. And see, they have options down here for multiple graphs, right? So that you can fool around with these options and see how you want to orient them, right? How you want to do that. Okay? So we'll stop there. Let me make a note where I left off here. So we left off with the box plots is where we ended. And quartiles and percentiles. Like I say, we won't use percentiles a ton. Quartiles will come up because of things like box plots. So you want to conceptually know what they are, but we don't have to go super deep with percentiles and quartiles as long as you know what it is. When I say the 37th percentile and you go, oh, that's the point where 37% of the data is below that, and then what, 63%, whatever number I said, the opposite of that, the 63% would be above it, right? So as long as you understand conceptually percentiles and quartiles, you should be pretty good because you're not generally going to have to calculate too many of them by hand, and if you do, you have StatCrunch to help you do it. Okay. Thanks for hanging in there. This was not my smoothest class that I've taught. It was I had a few other things going on, and then I got myself confused because I didn't have time to set up properly before class about which class it was. So thanks for hanging in there with me today. We'll be smoother next time. I'll be back on track. Just had stuff going on this morning. If you have any questions, stick around. Ask me questions. I'm happy to answer questions for you and help you out. Otherwise, do those things that you need to do to get caught up. Those of you who are caught up, great job. Keep up the good work, and I will see you next week. Okay, thanks, everybody. So I'm going to turn off the stream. Feel free to join me in Zoom.